All right, everyone, only 2 chapters to go. We are doing chapter 10. Chapter 10 is about hypothesis testing with 2 samples. So either 2 means, paired data, and 2 proportions. Okay, so studies often compare 2 groups, like a pill versus placebo, like anytime a pharmaceutical company is testing a new product, that's what they do. They have some people take the real stuff and some people take some fake stuff and they compare results. Or old versus new system. Okay, so to compare 2 means or proportions, you're going to work with 2 groups. Groups are classified as independent or matched pairs, which are dependent. So independent, sample values selected from one population are not related in any way to sample values selected from another. For example, if we're trying to compare SAT scores for students in Connecticut versus students in Oregon, you may make a hypothesis like the null hypothesis would be the SAT scores are the same. Alternative would be the students in Oregon have higher SAT scores than students in Connecticut, right? So that would be an example of an independent survey. Match pairs, samples are dependent, so each individual in one sample is paired up with an individual in the second sample in some meaningful way. For instance, you take the SATs today, and then you take a course to help you improve your score, and you take them again, so that the course really help. So are your new SAT scores higher than your old ones because of the course? All right, so let's break down the process for this hypothesis testing in each case. So if you have 2 population means with dependent samples and both standard deviations are unknown, population standard deviations. For this test, we're comparing the mean of sample 1, mu, with the mean of sample 2, mu2, or mu1 from sample 1, mu2 from sample 2. The null hypothesis is going to be set up like this. H0 is that the means, when you subtract them, equal 0. In other words, the means are equal. The alternative hypothesis is if you subtract them, they're not equal, or mu1 is less than mu2, or mu1 minus mu2 is less than 0, or the opposite, mu1 minus mu2 is greater than 0. So MyOpenMath, you're going to see the problems when you go down. The alternative hypothesis is always going to, or the null hypothesis is always going to be mu sub d, which is the difference in the means, represents mu1 minus mu2, okay? That's what MyOpenMath does. So we're going to let the calculator do the computations for the test statistic and the p-value, all right? So for these problems, the ones that are dependent, all right, we're going to use the t-test just like we did in chapter 9, all right? So we're going to have to figure out the mu d ourselves, and we're going to do that with our matrix feature or the table feature in stat edit. Okay, so here we go. Let's do an example. Does 10K running time decrease when the runner listens to music? All right, 9 runners were timed as they ran a 10K with and without listening to music. So it's dependent because you're testing a runner without music and with music. So it's dependent. All right, the running times are shown in the table. What can be concluded at the 5% level of significance? All right, so with music, we have these 9 runners, it looks like, and you have their times, the 10K, 44 minutes, 51 minutes. I need to probably be in my car to get that time. All right, so you have all those times with music, and then without music, looks like all of them have higher times, right? These are matched pairs, so they're dependent. We're going to use the t-test on the difference. So we're trying to, the means being equal is always going to be the null. So that means the difference has got to be equal to 0, right? Mu1 minus mu2 equals 0. And we're trying to figure out if the with music has a better time than without music. So we're testing the alternative mu1 less than mu2. Or if you subtract mu2 from both sides, mu1 minus mu2 is less than 0. Okay? So here we go. We need to put those into our calculator. So you can see the screenshots here, but we'll go through it together. So go to your calculator, and you're going to go to Stat, Edit. If you have stuff in there, remember go up and hit Clear Enter. Alrighty. We don't have stuff in there, so I'm just going to enter those values. So here we go. I got 44, 51, 44, 51. Oh, I forgot the next two already. 46, 46, 47, 49. So 46, 46, 47, 49. Oh, shoot. I just hit a bad button. So this one down here has got to be 49. And then let's see what are the last three. 40, 53, and 44. 40, 53, and 44. Okay, so those are the times with music. Hit your right arrow. Now you want times without music. So 50, 52, 49, 60, and then the other four, 50, or the other five, 50, 56, 52, and then 54, 47. Okay, so I'm testing to see whether those are equal, which means I'm testing to see whether their difference equals 0. So I got to go over here to L3 now, and instead of entering all the differences, which you could easily, 44 minus 50 is -6, 51 minus 52 is -1. You could easily do that. Or you go up and highlight L3 and hit second 1, which is L1, minus second 2, which is L2, and have the calculator calculate those for you. So there we go. There's L3. So those are the differences. They're all less than 0, which means the running times with music are better than the running times without music. But are they statistically sufficient to suggest that the alternative hypothesis is true? So here we go. I got to do the t-test on L3. So I'm going to go to second. Nope, not second. I'm just going to go to stat and over to tests. And I'm going to t-test, once again, because we do not know the standard deviations of the population. This time I want to put the data in. So boom, right there. Mu0 is 0, right? That's the difference in the means is 0. That comes from your null hypothesis. Then we go down here. The list in interest is L3. So you have to change that in this one. So second 3 gives you L3. The frequency is 1. Each of them happens one time. And I want to test if the difference is less than 0. So I got to go over there and select less than mu0. Then I go down to calculate. And there it is. The t-value is -0.3551. That is your test statistic. Your p-value is 0.0037. So let's go back to the notes. So P is less than alpha for sure, so we're going to reject H0. So there is sufficient evidence to suggest running times are lower with music. So if we were to do a final project in this course, that would be a great final project to do. You'd have to find 10 runners or 9 runners, whatever. That would have been a nice one to do. Okay, here we go. 2 population means with independent samples, and both sigmas are unknown. All right, so we're doing independent samples this time, which means we could do, well, the running one's a bad example, but independent samples would be like if you're comparing GPAs between sophomores and juniors, say, and you take a group of sophomores, group of juniors, they're independent because one group is sophomores and one group is juniors. So you'd be using this 2-samp t-test in that case. So the null hypothesis, as the other one was, is the means are equal. The alternative, the means are not equal, or the mean of from 1's greater than the mean, 2 or less than, okay? So here we go. We're going to do an example. Do rats take less time on average than hamsters to travel through a maze? The table below shows the times in seconds that the rats and hamsters took. Okay, so we have to enter those into our lists again. Our HO is going to be mu1 equals mu2, and our rats better than hamsters, so mu1 less than mu2 is going to be our alternative. So I go back into my calculator. I am going to go to stat, edit, and we want to clear out those lists. So let's see, where's my clear button on this calculator? I don't see a clear button. So what about delete? Oh, no, okay, what we're gonna do is this then. I don't have a clear button on this calculator unless I'm totally not seeing it. Oh well. There it is. So let's do this. We're just gonna reopen it. That'll clear it for me. All right, here we go. Now I'm gonna go to Stat, Edit, and I'm gonna put those lists in for the rats versus hamsters. So 28, 35, 18, 29. Well, there's the first four. And then 41, 26, 35, 34. And then the last two, 34 and 32. Okay, once again, if you get the answer wrong, check your lists first. Okay, make sure you got them exactly what MyOpenMath has. 30, 28, 37, 42. 30, 28, 47, 32. See, it's 37 and 42, though. I would have got it wrong. I know y'all said, oh no, you did it wrong, Blackbird, on the video. Okay, 48, 33, 50, 33. 48, 33, 50, 33. 48, 33, 50, 30, so 43, 42. So same number of rats has hamsters. Okay, don't need the difference in this case because we're going to use the 2SAMP t-test. So here we go. Stat, and then 2SAMP. Oh, I see the clear button now. That's funny. It's the big red button staring me in the face. You guys are probably getting a good laugh out of that one. All right, good. We can use that in the next video then. 2SAMP t-test. Here we go. I'm going to put data in then. Yeah, L1 is list 1. L2 is list 2. The frequency for each one is 1. Let's see. So my null hypothesis or my alternative was mu1 less than mu2. So I need that one again. And then down to calculate. And then lo and behold, you got a t-value. So the test statistic is negative 2.380. The p-value is 0.0145. So we are at a 1% level of significance. So that means that 0.0145 is bigger than alpha. So we failed to reject H0, right? Last example, we rejected H0. This one, we failed to reject it. So there's insufficient evidence to suggest that the mean time for rats in the maze is less than the mean time for hamsters in the maze. Okay? So this example uses data. There's going to be examples where the mean and standard deviation will be given. You're going to have to do the 2SAMP t-test with stats in that case, but you should be used to that. All right, you'll be able to put that in the inputs and take care of business. All right, last kind of problem in this chapter, comparing two independent population proportions. For these problems, we're going to use the 2-prop-z test. So if P1 is the proportion for the first population and P2 is the proportion for the second population, then we set the hypotheses up like this. P1 equals P2 is the H0, and then, you get your alternative with the does not equals less than or greater than. Okay. Is the proportion of wildfires caused by humans in the South different than the proportion of wildfires caused by humans in the West? Okay, in the South, we got 380 of the 514 randomly selected wildfires were caused by humans, and 363 out west out of the 511 were caused by humans. So what can be concluded at the 10% level of significance? So here we go. This time they give you alpha, right? A lot of times they give you the other value, the 95%. Like up in this one. Oh no, it gave you the alpha in that one too. All right, well they're giving us alpha. Boy, All right, here we go. So we're going to use the two-prop z-test on this one again. Or we didn't use that yet, so we're going to use it in this one. So stat tests two-prop z-test is number 6. And we're going to go now we do the successes over the total, right? So in the first one, for if success is lighting a fire, I guess 380 out of 514. So 380 fires lit by humans out of 514. A lot more thunderstorms in the south than there are in the Willamette Valley, but so it seems to me like more fires would be caused by humans here, but I guess there's a lot of thunderstorms in the mountains. 363 out of 511. 363 out of 511. And are they different? So we're going to choose does not equal. Okay? Calculate it. Yeah, p-value is really high. It's 0.2998, right? The test statistics 1.037. That's basically one standard deviation above the mean. So that's not that significant of a result. So we're definitely going to be fail to reject H0 in this case, right? So P is greater than alpha because you got this p-value close to 0.30 and the level of significance was 10%. So we're way more than 10%. We fail to reject H0 then, so there's insufficient evidence to suggest that the proportion of wildfires caused by humans in the south is different than the proportion of wildfires caused by humans in the west. Alrighty, so that is comparing two samples, hypothesis testing, comparing two samples in a nutshell. This homework assignment I don't think is too bad. Enjoy it. Please reach out with any questions. We'll see you in chapter 12.